So we all live somewhere, right? Like that's not too big of an assumption to make. Um, we live somewhere. Maybe we live in a city. Maybe we live in a smaller town. This is kind of an introduction to the way that data visualization works, not just in the way that D3 works, but kind of data visualization as a whole. It's a conceptual framework that we can call visual variables that is baked into D3. And once you kind of internalize these ideas, D3 becomes so much easier. So we have a bunch of cities. How many cities do we want to have? Say 4 or 5. Let's take a vote. How many do we want? Throw it in there in the chat. 4, 5, 5, 5. So I actually don't remember how many cities it is. We have 5 cities. So congratulations, everyone who said 5. Sorry to the 3 people who said 4. Maybe next time we can do it with 4 instead. So we got a few cities here. What is the biggest difference if you have a bunch of cities? What's the easiest thing to compare about them? Don't say where they are. Say something else besides where they are. What can we use to compare? It's like we're cheating. So I like to think that you already know all of the things that I teach you. It's just a matter of coaxing it out of you. And so yes, okay, Steve, actually, their name is a very, very interesting one. So we do know their name right now, and that's something we don't necessarily talk about a lot, but we'll come back to it later. So we know their name, and we're going to go with population here. So if we had 5 circles, and we want to make these circles not just represent the cities, right? Because each one of these circles is a city. Let's say we had a spreadsheet, right? We have a spreadsheet, every single row has a city in it. We have a column of that spreadsheet and it says population. What do we want to do to these circles to reflect the population? What can we change about these circles in order to... So the best thing about this is that size is definitely the right answer here, but that's not what we change first. It's not what we change first. What can we change besides? Yeah, thank you for color. I appreciate that. You're making my life much easier now. So yes, color. Which of these cities has the fewest number of people in it? DC, sure. And which one has the most? How do you know that? Like if you just looked at this, you would somehow be able to tell that DC has the least and that Delhi has the most. And that's because Delhi is just more intense. It's like, I got a lot of color here. And DC's like, I don't have very much color here. And then everything else is kind of in the middle. So LA, is the second most. And then Moscow, Jakarta, from what we're looking at, they're kind of the same, right? But Delhi's definitely the most and DC's definitely the least. So what we're doing here is we're taking something that's numeric. We're taking part of our data, a number, the population, and we're encoding it as something visual. This is called visual encoding, clearly, because I used those 2 words a second ago. So we're taking that population, we're encoding it as color. And remind me again what we should have done instead of changing the color. What should we have changed? Yeah, the size, right? That would have probably made more sense. And so yes, we can do it the same way. Which was easier to see the difference in, the color or the size? Yeah, so it depends on the person. It depends on what you're thinking about when you're making those sorts of comparisons. But when you are building a visualization, probably the biggest decision you have to make is you have to figure out what in your data, such as your population, what are you going to represent that as visually? Are you going to represent that with area of a circle? Are you going to represent that as intensity of a color? Are you going to represent that as position on a page? Any of those things. And so this is what D3 does. This is what we need to internalize. The idea that we have our data over here, and we have a visual representation of our data over here, and we somehow have to connect them. So right now we're connecting the number of population to the size. And even though I saw radius before, it's technically area, but you know, size would be more friendly for people who experience different aspects of color blindness. Definitely, definitely. So because of the fact that we have these different sizes, we could actually overlap them, right? What is this axis, the x-axis, going left to right? What column in our data set is that representing right now? Because it is representing data, but what changes as you go left to right here? Steve, you said the answer already. Yes, so yeah, city name, right? And so we can actually, because we're labeling them, someone said, you know, a legend is important. If we stack them on top of one another, we can still tell they're different. We're still changing the size. We don't necessarily need to say, oh, city name is this axis here. We just stack them on top of each other. We could also change position and put them on a line chart like this. So what is this over here? What if I had a city and it was right here? What size would that city be? What would the population of that city be? Yeah, 0, right? So it's something that we already kind of know. We know that the smallest number here, all the way on this side, is going to be 0. What's the population on the far right-hand side? And you're like, I don't know. It's lots. It's whatever the maximum number is, right? And we'll come across that a little bit later. So yeah, this is kind of the idea of how things work. It's the idea that when you are trying to kind of put something onto a page, you have to think about the minimums and the maximums. So on this visual right now, the minimum we can represent is 0. And then the largest thing we can represent is whatever the population of Delhi is. We called it X, someone called it lots. That's all the same. So it's just, this is our maximum over here. I've never used annotations on Zoom before, so I'm very excited about it. Okay, what does this color represent now? So we've added color back in there. What does it represent to us? Yes, different cities. It doesn't actually mean anything. How do you know that this doesn't mean population? How do you know that, let's say, this teal color here is the smallest color, and this pink color over here is the biggest color? Yeah, so there's no ordering between it. So yeah, sure, no legend, yes, but probably more accurately, it's the idea that the colors don't flow, right? It's not a gradual change from one color to another color. They're different categories. So do we need color on this visualization? What does it add anything? No. Yeah, the point of this is just, I wanted to make it a little bit fancier, right? So I threw some color on there. So that is the way that we take some sort of column and translate it into something that is visual. If we have this one right here, what color is a 0 population? If I had 0 people in a city, it would be white. But isn't DC white? Does DC have 0 people? Yes, I am recording. Let me make sure I'm recording this. It should be recording. Yeah, it's recording. Yes, I will be sending this out to everybody. Yeah, so the issue is that DC is just almost white. It's pretty tiny. Has anyone lived in DC? It's a pretty small place. Yeah, like everybody there is just, they commute from like Northern Virginia or Maryland, and they're like 6 people live in DC. I guess it's gotten bigger, but you know. So yes, there are people there. You just can't tell the difference between something that's totally white and something that's DC. Whereas here, it's easy to say, how big would a circle be if there were 0 people in it? Yeah, so you would just make it maximally small. In theory, it would be invisible. But usually you start off with like, a pixel or 2 pixels, 3 pixels, just so it's something that people can see. So just drill this into your head one more time. What we're trying to do here is we're trying to think of our range of what the smallest value is and the biggest value is. So 0 to deli. And then we try to figure out what's our visual representation of this. So, 3 pixels radius to however many this is. Technically area, but that's fine. Same thing for this. This is 0, this is deli, going on and on. All right, we ready to learn D3? We're good to go. We know everything about visual encoding. Life is perfect. We're ready. Can I get a yes? Can I get 100 yeses or 57 yeses, if that sounds fine? Beautiful. Okay, so this is the concept that D3 is built on. And you're like, well, what is D3, right? Excellent question. So in the world of programming, there are different programming languages that you can write code in. All programming languages can kind of do everything, but only kind of. If you learn something like JavaScript, JavaScript is for the web. It's a programming language that lives in your browser and runs on probably every website that you visit. So if you want to learn something, if you want to learn ways to code that are specifically for the web, you want to learn JavaScript. If you want to learn data analysis, you'd probably learn a programming language like R or Python. In the lead program, we use Python. In more like the stats world, social sciences, quantitative stuff world, they use R a lot more. And that's because these programming languages are a little bit more geared towards working with data. You can do data work with JavaScript, but I feel like everyone that does it must be a sociopath because it's not really, it's nuts, they're nuts. And if you just want to kind of do everything in the world, then you're going to learn Python, probably. And that's what we do in lead. You can scrape with it. You can analyze data with it. You can build visualizations with it. You can kind of do everything with it. But in the end, all programming languages are the same. Usually the way that class works when I teach D3 is I've had many, many classes of Python with my students. And they're like Python experts, Python, 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 all the time, 5 days a week. And then I sit them down in front of JavaScript. And I say, congratulations, it's time for a new programming language. Who's excited? And everyone's like, no, because they just suffered so much learning Python. It was a miserable experience. Everyone wanted to die all the time. It was awful. And then it turns out that, oh, all of these concepts that we learned with JavaScript just apply directly, or all the things that we learned with Python apply directly to JavaScript. Like programming is programming is programming. There will be little changes between different kinds of programs or different kinds of programming languages that you use. But in the end, coding is coding, and the way that you learn it, you can transfer it to anywhere else. So I myself learned to code on the web. I learned HTML, JavaScript, things like that, things that you use to build web pages. And it's just because it's really easy, right? You can throw it up on the internet. Everyone can see it. You don't need to install weird things on your computer because you're, Chrome, Safari, Firefox, these can all do all of this programming stuff without you needing to install any other tools. So it's super easy, super fine. And then I moved on from there and I learned there was other programming. It was awful, it was terrible. But because I had already learned to code in JavaScript and HTML, CSS, these things we'll talk about in a second, they were all transferable, so life became nice and easy. So what we're gonna do, I'm gonna share my screen once again. And I'm gonna send you a link to the page that we are gonna be working on. So this website is called Codepen, and it is a place where you can, yours probably looks like this, perhaps, when you click on that. It's just a web page where you can code things that are for the web. We have 3 different boxes here, probably up at the top for you. The one on the far left is called HTML. HTML is the building blocks of every single web page that you look at. It's the kind of code that says, hey, this is a big title. Hey, this is some text. Hey, this is a title, but not as big as this title. Hey, this should be bold. Hey, this is a link, things like that. It doesn't say how things should look. It just says what things are. It just architects the content on the page. This middle box here is CSS, which stands for the hilarious cascading style sheets. This says, here's what the page should look like. If you want the page background to be red, or you want your links to be pink, or you want your font to be Comic Sans, anything like that, that's all display. So you change all of this through CSS. On the right-hand side, we have JavaScript, which I like to describe as advanced functionality. So if you have interactive charts, if you have like something following the mouse around, if you have an annoying chat box that pops up that says, hey, do you want to sign up for our newsletter? Those things are all JavaScript. So what we're going to be learning today is D3. D3 is a JavaScript library that lets us create interactive data visualizations. Now, when I say it's a library, a JavaScript library, if I want to make a bar chart, am I the first person on the planet to ever want to make a bar chart? Say no. Yeah, correct. No, I'm not. So do we think that someone else on the planet has written some code to maybe produce a bar chart? One of those early pioneers of bar charts on the internet, right? Yeah, probably. So most of the time, what you're doing when you're programming is not that you're doing everything from scratch. You're not doing everything from square one, but you're kind of finding code that other people wrote and then stealing it and using it. So several ways you can do this. You can just Google for answers. Random people will have posts on the internet. You can try to cut and paste their code. Sometimes it works, sometimes it doesn't. That's the very first thing I have you do on the very first day of class. But what we're doing here is D3 is not just random code on the internet. It's code that someone put together in a nice, formal, organized way to make it easy for us to use. This is called a library. It's not just code that someone wrote. It's code that someone wrote that they want you to use. They wrote it in a way that is kind of user-friendly. I say this because D3 is incredibly difficult to kind of get your brain around in the very, very beginning until you get those beginning concepts down. So what we're doing is we're using the programming language JavaScript in order to use a library, code other people wrote, called D3, in order to put charts and graphs and stuff on the page. The page itself being made out of HTML, and then CSS is the styles of it. Yes, ask questions all the time, So question, so D3 is a library that is itself organized in libraries. So what you consider a library can kind of change depending on kind of your approach. D3 is built up of different modules. Like you could pull the bar chart thing or the actually, no, there's not really a bar chart thing. Like the tooltips part of D3 or the hover part of D3 or the part of D3 that's all about changing colors of things. I wouldn't necessarily call those libraries. I would just call those parts of D3. But there are plenty of libraries that are made up of smaller libraries. And pretty much everyone in the world, every time you write code, you're using someone else's code as well. So it's very rare that you're going to write something that's 100% yourself. Usually going to be using libraries, and those libraries will also be made up of libraries. So is it like GitHub? So GitHub we'll call a social coding platform. So what GitHub is is it's a website where, we'll just go to my stuff, where people can post code that they have written. For example, this is code that I've written. This is a library called Persign. And what Persign allows people to do is do analysis on algorithmic recommendation systems like YouTube or Amazon or things like that. And it basically, you run this code and it just drives a browser around the internet and sees what is recommended to you by something like YouTube or by something like Amazon. Because people say things like, oh, if you watch like, one video on YouTube, they send you down a crazy rabbit hole. None of the research is very reproducible about that. So I built this, released it a few months ago. If someone wants to use this library to do research, they can just easily install it. If you actually want to use this library to do research, you don't even know how to code, or you don't need to know how to code. If you scroll down, there's a link right here where you can see it in action. And if you just click that link, you can run it all yourself and everything is magically set up in the browser for you. So it's a delight. But yeah, GitHub is a place where people will post their code in a very formal way. And so a lot of these libraries are hosted on GitHub. And this is something we spent a lot of time on in the program, what is the world of programming? Because it's not just you sitting in a dark basement with your headphones on at 2 a.m., trying to bang out some code. It really is a community of people all around the world that you interact with in many, many, many different ways. Any other questions so far? All right, let's get rolling on some coding. So what we talked about already. First, let's make your Codepen look like my Codepen. So I want to make sure we're on Intro to D3 Part 1 Scales. I'm going to drop the link into the chat again. I want you to change the view to be either this one or this one. So either all the boxes are on the right or all the boxes are on the left. I'm going to keep mine on the right just because it's easier for me to deal with right now. And once it's here, I'm actually not interested in any of these boxes this time, so I'm just going to push them all to the side. So what we're going to do now is we're going to use the most important part of D3. The most important part of D3 is not making graphs. The most important part of D3 is not building visuals. The most important part of D3 is actually scales. So what a scale is in D3 is, we'll start like this. Let's say we have the number 0 and we have the number 100. Give me a color to be represented by 100. Just throw a color out there. What's a good color? Blue? Someone say red, because I got it. I need it to be red. Red, yeah. Thanks, great. So we have red over here. What's our color for 0 going to be? Why white? Everyone seems to be saying white. No, I like white. I like white. I think it's the right answer here. Yeah, because it's basically like no color is the way that people kind of think of it. Okay. So what we want in theory, if we were building a visual and we had a city that had 0 population, it would be white. If we had a city that had 100 population, what color would it be? Say red. Yeah, red, obviously. If we had a city that had a 50 population, what color would the city be with a population of 50? Right, whitish red. This is just, I think it's hilarious every time I say it. Whitish red, yeah, right? So something in the middle, which I don't know how to do that in this guy here. So, okay. So that is all we're going to have D3 do for us. On the bottom left-hand corner, there's something called console. I would like for you to click console over here. And it pulls up this thing where we can write code ourselves. If we want to write code ourselves, bottom left-hand corner console, type 2 + 2 and hit enter. And what does it say? 4, amazing. What if we do 10 + 10? What does it say? 20, yes, amazing. We're programmers, we're programming. This is genius. This is not D3, this is just JavaScript. It's just JavaScript. So the point of D3 is to, can you resend the Codepen link? Yes, absolutely. I hope that that link works. All right, so what we want to do is we want to say, hey D3, we have input numbers from 0 to 100 or 0 to Delhi or whatever, and we want to figure out how to turn that into something visual. So we want to make it white to red, or from like something on the left to something on the right, things like that. And you say, how do we do that? And I say, scroll down, we're just going to steal this code right here. Now, if this were a real class, I'd have like 3 hours, and we would go through this piece by piece, beautiful and slowly. But no, we're not doing that. What I want you to do is just cut and paste this code. The very first step of programming is to not think, but to just do. So where it says scale equals D3, scale linear, domain 0, 10, range 0, 100, just cut and paste it. Paste it down here and hit enter. And if it looks like a bunch of garbage, then you did it right. And we'll just leave it there for a second. So what we do for D3, what we need to do, so we might need gamma justification to make the white-red color scale work right and natural for our eyes right. So the issue with trying to be specific with color is, in the grand scheme of things, color is actually a very imprecise way to convey information. It's very easy to say this one's very much lighter, this one's very much darker. But when it comes down to it, color is not good for nuance. So you don't really need to be that particular about it. You have to think about things like color blindness. You have to think about things like what you're actually trying to communicate with the visualization. But in the grand scheme of things, we don't need to nitpick about the specifics of things like gamma and things like that, just because color's strength is being attractive, being visible, and not, it says D3 is not defined. Interesting, interesting. Does it say D3 is not defined for everybody? No, okay, I don't know. I don't know the answer, Diana. If you get input min is not defined, make sure you're cutting and pasting this second one here, not this first one here. We want this second one down here. So what we want to do here is D3 is going to do all of our hard work for us. If we have a chart, let's say you have a chart like this. We have a chart like this, and let's say this is 1990, and this is 2010. These are our inputs. These are the things we're going to be saying, hey, this is our actual original data. How far from the left-hand side is 1990? If we're like pixels, how far from the left-hand side is the beginning of this line here? Say 0. Yeah, so you know, it's 0. And how far do we want to pretend this is? Like 100? That's unreasonable? Yeah, sure. Why not? 100. Sounds great. So what I'm going to do is if I say, hey, D3, I have something that's a data point for 1990. Where do I put that? What is D3 going to tell me? Say 0. Yeah, right? And if I say D3, I have a data point, it's 2010. Where is D3 going to tell me to put it? And if I have a data point that is the year 2000, where is D3 going to tell me to put it? Right, 50. So this is what scales are in D3. Scales are an automatic way of doing this process here. Now, do I see the words? Do I see the words? I see the word scale. I'm making a scale using D3. Do I see the words input and output here? Instead of input and output, I have domain and range. Why? Because they want to make it complicated for us. They don't want to make our lives easy. So when I say input, you say domain. So 1990 is an input. No, wait, it's not an input. It is the, say domain. Great. And if that's the domain, what is output? Yeah, it's the range. So if we look at this code right here, that's saying we're going to have an input between 0 and 10, and you're going to give me an output between 0 and 100. So if I type, if I turn off annotations, if I type scale 5, what is it going to give me back? What's it going to give me back? $50, right? Now, so far you're like, you're an idiot. You're an idiot. This is stupid and this is easy, right? Like you're just multiplying by 10, right? If I do 8, it's going to give me 80, things like that. Now the issue comes, the first issue is if instead of 0 to 10 and 0 to 100, let's say I have 1990, let's say 1992 to 2012. What if I do that instead, right? Now it's pretty easy to say if I have 1990 to 2010, 2000 is going to be 50. But if you look at this, if this is 1992 and this is 2012, what's halfway between it? I have no idea. I have no idea. So I have to do scale 2000, and it says, oh, that's going to be 40. That's going to be 40. I could do scale 2010. Oh, that's 90. So this is the magic of D3. The magic of D3 is you set the input range, the output range, it automatically translates it for us, right? So when I want to build that chart, if I'm talking about the length of a bar, how do I input those years again? So I copy and pasted this code right here, and then I pasted it right here, and then I just changed domain where it says 0, 1992, and 10 gets changed to 2012. Here, I'll even paste this code right there. You can just cut and paste that. So what do you mean by doing it the other way around? Like go from, like if I have 40, can I get back to see what number that represents? And the answer is yes. It's scale.invert or something. Is that what it is? Yeah. So I can say, what is 40 pixels? And it says that's 2000. That's more advanced. You don't use that very often. But so this is the point of D3. That's the magic of D3. It helps with positioning things. It helps with making things tall, helps with making things wide. What is this? What is something that we've done that you think this wouldn't help with? That you think, oh, that's impossible. That's impossible. Colors, right? Right? Of course. Yeah. Sure, Steve. Why would it possibly work with colors, right? So let's say we have an input of 0 to 10, like 0 to 10 million people maybe. Our outputs, I want something between white and red. I put little quotation marks around white and around red. Run that code. And then ask it, what color is 5? I didn't even have to do RGB. If you know about RGB, if you know about hex colors, I didn't have to do any of that. I just said, I'm going to give you 0 to 10, and I want you to give me back something between white and red. If I do scale 5, it gives me this. What is this? Oh, it's computer stuff. Who cares? If we just Google it, we can see, what color is this? Whitish red, amazing, it's amazing. Yeah, so there's CSS colors, they're colors that work in Photoshop, they're colors that work everywhere. It's amounts of red, amounts of green, and amounts of blue. So yeah, this is really how, like, this is the magic. This is what makes D3 great. Everything else you do with D3 is like rec. Every time there are new JavaScript libraries that focus on data visualization, they always make they improve on the other parts of D3. They make it easier to make a bar chart or make a circle or make things like that. But they always, always, always use D3 for scales just because it works so well. There are a bunch of other kinds of scales that live inside of D3. This isn't, like if you're trying to make circles different sizes, there's like a radius scale and other kinds. Ones that you do for categories, ones that you do for spacing out dots, spacing out bars, things like that. But there you go. That is what D3 is. It's great for. It's great for. Any questions before we move on? A good question might be, how long am I going to do this? Let's go until like 12:15, and that will be the end of me talking about coding stuff, I think. Because I feel like we're making slow but decent progress here. All right, so no questions before we move on? All right, next up. Here's another Codepen for you. Is Codepen working okay for you all? Does it seem acceptable? Good, because like I said, I've never used it before. I mean, I've used it. Everyone on the internet uses it, but I've never taught D3 like this. Okay. Oh no, I have to back up. I have to quiz you about something. So remember how I said HTML is code that represents the stuff on a page. If I look at this right here, it says H1. D3 scales as H1. H1 is like the #1 header. It's the biggest header. This is the beginning of the header. This is the end of the header. You're like, why does it look like that? Doesn't matter. Doesn't matter. Beginning of the header, end of the header. It's the best header. It's the truest, largest, most incredible. What if I wanted to make this header a little bit smaller or make it a little less important? What do you think I might change H1 to? Change it to H2. Oh, look, it got smaller. What if I change it to H4? Oh, it gets even smaller. What's smaller than H4? H5, great. What's smaller than H5? Great. What's smaller than H6? Yeah, there's no H7. There's no H7. H7 doesn't exist. Why? They decided at some point they just had to give up. What do you think P stands for? So if H means header, P stands for, yeah, paragraph, right? Strong is the new way of saying bold, just like M is the new way of saying italic. What else do we have here? We've got code, which represents code. LI, which means list item, an item in a list. But all you need to know, does CSS define the header style? Yeah, so technically I could do something like make every H1 have red color. And then, wait, I think I might change the color down here. Change the color in here. Change the color somewhere. Oh, is that an H2? Is that why it's doing it? No, mystery, mystery. Nothing is updating here. Oh, it's fighting with Bootstrap. Ugh, ugh. So yes, CSS defines the way that things look. So the point is, there are all of these things called tags. P is paragraph, H3 is a smaller header, H1 is a really big header. What we want to do now is there's this thing called SVG, which is a way of, does anyone use Illustrator, Adobe Illustrator? The difference between Illustrator and Photoshop is that Photoshop is based on pixels, whereas Illustrator is based on like shapes and like, here's the coordinates of this circle, here's the coordinates of this line, things like that. So what we're going to do here is if we scroll down, we scroll down, we scroll down, we scroll down, we see a tag right here for an SVG. It says, hey, you're going to make an SVG, scalable vector graphics. It's graphics that are based on shapes and coordinates, not on pixels. So we're going to make a vector graphic. It's going to height is 500, its width is 600. We can see the box right here. So if P is a paragraph, if small is for small stuff, if code is for code, if H1 is a #1 header, what do we think the element is for a circle? Or the tag name is for a circle? Spoiler alert, it's already on the page. So you could just say circle and you would see that it's there. So type circle like this inside of the SVG. So I put a H1 on the page, a header shows up. I put a P on the page, a paragraph shows up. I put an SVG thing on the page, some sort of box shows up. I put a circle on the page though, and I don't see a circle here. I don't see a circle. What do we need for a circle in order to like make it appear? In order to say, circle, you are a thing. Yeah, a radius, right? So in the same way that we can do height and width here, I'm gonna do circle R equals 10. And I'm gonna put that in quotes right here. Did I get a circle? What it, okay, all of you were saying yes, but that really looks like a slice of pizza up there. Yeah, so what went wrong? Yeah. So what's happening is the center is right here, right in this upper left-hand corner. And so the rest of the circle is going like this, but it's outside of the shape where we said, hey, you can draw here. So we're not able to see it. So if we want to move it, what do you think? If you know the answer to this, don't say it. What do you think we will add here? So R is the radius. If we wanted to do the position, like X and Y, for example, what do we think we might put here? Say X and Y. Yeah, X and Y seems reasonable. So let's do like X 20, Y 20, because why not? Did that work? Are we sad? Do we feel like we failed? Because we have. That's all programming is, right? So there are two rules. Well, no. When I ask a question, there are only two answers. One, either I give you the right answer, or two, I'm setting you up for failure. In this case, I was setting you up for failure because it's obviously X and Y, but it's also obviously not X and Y. It's CX and CY because it's the center X and the center Y. How exciting, right? You've never been more excited. Like, man, look at that. Incredible, incredible. What's another shape that people like? Any favorite shapes here? Rectangles, maybe? Say rectangle. It's easier. Yeah, I can't do a triangle for you. I mean, we could. It's too much work. It's too much work. Okay. I'm done. I'm quitting. This is awful. Actually, what I'm here, first, we're going to do this. We're going to do a rectangle. If the circle needed a radius, a CX and a CY, do you need quotation marks? I think it will work without them. I'm pretty sure it'll work without them. But it's better if you have them there. The best and worst thing about HTML and JavaScript is that they're written by like literally every human being who's ever breathed. Like babies, they come out of the womb, they automatically start writing it. People who are dead, they're in their graves, they're doing it. Like anyone does it, everyone does it. So the browser is like, oh, you're probably really stupid, so I'm just gonna make it work. I'm gonna make it work. Like no matter what, I understand what you're trying to do, so I'm gonna make it work. For example, if I get rid of like this p tag right here, this end of the p tag, the page still works fine because it's like, oh, you were just too stupid to put it there. So even if you do things kind of wrong, it'll still probably work. So, all right, these are called attributes, R, CX, CY, width, height. What attributes do we think we need to make a rectangle exist? Width and height, sure. We can do width is what, 300, height is 100. My circle's gone. What do you think I need to add in order to like move this out of the way of my circle? Yeah, the rectangle ate it up. So here's the secret. It is X and Y, not CX and CY, because CX and CY is center X and center Y, whereas X and Y is going to be our top left-hand corner. And you're like, how am I supposed to know that? You learn it. You learn it. That's how it works. The best thing about programming, D3, even if you're me, is you'll be making a visual with circles and none of your circles will be showing up. None of your circles, and you're so angry and you're like, what's going on? My code's broken. And it's because you used X and Y instead of CX and CY. So I've been using D3 since like when it first came out and I still make these mistakes. What do we want to change about these shapes? Anything? Say something very easy or I'll be so unhappy. All right, color, great. People who use Illustrator, what are the two different things that, like, you don't just pick one color for things in Illustrator. Yeah, fill and stroke. Fill and stroke are the two different things that exist for color. D3 just celebrated its 10th birthday within the past month or so. And the best thing is that over time, it has gotten less usable and more confusing. So when I started using D3, it was nice and easy. And then as time went on, it was kind of adjusted to be better programmatically and to work better in using words like tree shaking. Like tree shaking, what's that? Not just a way that you can get apples. It's something that has to do with programming. And due to tree shaking, they had to rename a bunch of stuff to make it awful. So yes, we want to change the fill and the stroke. So hey, fill equals red. Stroke is pink. So much fun. Oh, what is it? Stroke width equals 10. Is that it? There we go. Yeah, so if we want to color things, we just say, hey, use fill, use stroke, and that's it. And that's it. So why the hell am I making you learn this, right? Like, what's the point? What's the point of any of this stuff? So when you use D3, there are a few different ways to manipulate things in D3 and build visuals, but probably the most common way of doing it is to use D3 to draw SVG elements on a page. So when I have this right here, this is SVG. Each one of these is an SVG circle. I am setting the X and the Y in order to position them on the page. When I have this right here, I'm setting the fill color here, 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 and here. D3's job is to manipulate this to set the fill color according to my scale. I say something like, DC has 700,000 people, Delhi has a bazillion people, color it accordingly. So D3 is kind of the glue that attaches SVG to our original data. So any questions about SVG before we actually move on to, I think, our last piece where we connect D3 and SVG? So we get this. There are shapes. They come with element names. We can change them. It's nothing's too crazy about them. You can make them very ugly. All right. Making D3 and SVG work together. What's the advantage to drawing these in CSS? So by CSS, do you mean, so we're using SVG for all of our shapes here. The role that CSS plays is styling things. You can bring in CSS to this, but we're gonna push that to the side now because it gets kind of complicated. We're doing this kind of like the bad busted way, just because it's easier, for now. So I hope you enjoyed this. If you are leaving, we have this D3 and SVG right here. This now is the time to get excited. Who is excited? Is anyone excited? Ready to become experts? Yeah, okay, good. So if we look, so reminder, if yours doesn't look like this, change view and then just click the editor layout here. What are these elements here? What is the SVG element for a rectangle? Who remembers? We just saw it a hot second ago. Rectangle, yeah, obviously. How about these ones here that are circles? The circle element is a circle. Yeah, so easy, so easy. So usually you don't do it like this, but I already put all of our rectangles and circles in here. And we're now going to use D3 to reach out onto the page and change these rectangles and change these circles. So I'm going to hide this. I'm going to hide the CSS, and I'm just going to go inside of this awful, crazy, insane JavaScript area. First thing I'm going to do is I'm just going to put some extra lines right here after this weird first line, but before this weird second line. So I'm just making a bunch of space right in here. If I want to ask D3 to do something, what two characters do you think I type to say, hey, D3? Yeah, good work, D3. I want D3 to reach out onto the page, and I want it to grab one of those rectangles. So I'm going to say, D3, could you do me a favor? Could you select one of those rectangles? And I save it, and nothing happens. Okay. What's something we could change about this rectangle? Because I don't know if this worked, right? Like, sure, color. What color do you want it to be? Pink? Sounds great. So what are these things called? Fill, R, CX, CY. I said this word once and you probably forgot it. Does anyone know the answer? This is a tag. Oh, attribute. Okay, you all are geniuses. You know everything. Sorry, I'll just hand over class to you. I want to change the attribute of, is it called color? What's it called if I want to fill it in? I want to change the fill to be pink. And what happens to that fill? It turns pink. What a delight. What a delight. Are we satisfied with this? Are we satisfied with just changing one of those rectangles? Yeah, so excellent question. Does it choose the first rectangle it finds? Yes. So what it's doing is it's saying, I'm saying, hey, go find a rectangle. And then D3 goes out and it's like, I found a rectangle. I'm lazy, so I'm done now. And it's not going to find any more of them. So if we wanted to select all of the rectangles, Oh, yeah, good question, Lauren. I'm an awful programmer, so I never do a good job only using one kind of quotation mark. Yes, as long as you start and end with the same kind of quotation mark, they are interchangeable. Yes, so if instead of select, I do select all. I don't know the answer to that, Gabriel. Like having it autocomplete stuff? I don't know. That's a mystery to me. Oh, will I send the Codepen link? Of course. Of course. Great, it selected all of them. It changed them all to pink. How exciting. Who's excited? Me. What else can we change about them? Stroke color, size, width. Let's go with width. Let's go with width. .attr width. Let's just make it 0. No, we'll make it 100. Why not? I'm really irritated by this wrapping, so I'm gonna hit enter before every period and break them out onto multiple lines. I think I have a package. Hold on. Thanks a lot. I got a package. How exciting. How exciting. And I learned that the doorbell in here kind of works. So it seems like I'm using a period to stitch together commands. Yes. So a really fun thing about JavaScript is it's kind of like, nah, do whatever you want. I'm going to make it work. So as long as I put a period at the beginning of each one of these lines, instead of like this, it'll work. This is called chaining, when you chain together a bunch of different commands. When can you use it? How can you use it? It's very specific to what library you're using, but it works pretty well. Okay. All right. Do you want the secret? No, I'm not going to tell you the secret yet. I'm not going to do it yet. All right. Let's do some. Yeah, I'll give you secrets in. I'll give you secrets in 6 minutes. 6 minutes for the secrets. Okay. Let's. If we are building a visualization, do we want to have all of our rectangles pink 100 width? Do we want them all to be the same? Or maybe we want them to be different, right? We want them to be different. Based on what? What's it related to? Like, what should this be related to, or this? Yeah, the city or whatever, right? So what I want you to do is cut this, and we're going to paste it down at the bottom after I say all these random words here. So take the code we just wrote from the top, and then we're going to move it down to the bottom. And I'll paste all of this code. Actually, I think if you just refresh the Codepen, you'll get all of my code, I think. All right, so what we want to do, no matter what all of these dumb words that I wrote say, wow, it's so many words. What we want to do is we want to say, hey, we have all this data here. And you're like, Soma, I don't know JavaScript. I don't even know where this random weird squiggly thing is on my keyboard. Like, how am I supposed to understand what's going on? And I say, hey, here's all you need to know. This is New York City. What's the population of New York City according to my code? Say 8. Yeah, right? What's the population of LA? Yeah, 4, right? Like, you don't need to know how to program to know that like these things are grouped together. So what we want to do is we want to take all of this data and attach it to our rectangles. So here's what I'm going to do. I'm going to grab all those rectangles, and then I'm going to attach my cities to it. I said .data cities, because these are all of my cities. If you are someone who has never programmed before, This is probably where you start to lose your mind, but that's fine. Everyone has to start somewhere. So when we're using D3, when we're using .attr, there are two different ways that we can use it. One way, we can say, I want every single one of my rectangles, every single one of my visual elements to be the same. I want every single one of my fills to be pink. I want every single one of my widths to be 100. And the way that you do that is the way that we just did, is we say, hey, here's fill, make them pink. Here's width, make them 100. But there's another way to do it too. The other way is I want to change things on a per element basis. I want every rectangle to potentially have a different width. I want every rectangle to potentially have a different color. I want something from my data set to be represented visually on my visual representation of that. So right now, I don't think we want the color to change based on the data, right? But we probably do want the width to change based on our data. What do I use in order to make my width change based on the data? Say this thing right here. If we were in class, you would say function D, but we're not in class. So you just have to like cut and paste and put that in the chat or something, I guess. Who knows? Oh, you know what? We can actually do this a fancier way. So we're going to do this. Oh, this is going to be awful. We'll be fine. We'll be fine. Take this code and use it in place of whatever width code you have. If instead of just saying pink or 100 or something here, I do this wild and crazy thing here, function D, this is code that gets run for every single one of my rectangles. It goes to the first rectangle and it says, hey, what should your width be? And I return it 100. It goes to the second rectangle and it says, what should your width be? And I return it 100. Where have we defined function D? You have not defined function D. You have not defined function D. D is our data point. This is technically called an anonymous function. It's a function without a name. Another way of writing this would be slightly more attractive, and it would be this. Here, let's do it like this. I don't need to explain anything to you. Oh no, is that not going to work? Oh, please make that thing go away. Yeah, we'll leave it like this. So what D is our data point. D is our data point. What do we know about each one of our data points? We know 3 things about every data point. We know its name, we know its population, and we know its area, right? If I wanted to say, make New York City be 8 pixels wide, make Tokyo be 14 pixels wide, make LA be 4 pixels wide, I could say d.population. I could say, take that data point, take that city that we're looking at, grab the population, and send it off to be the width. So this one right here is 8, this one's 14, those are also small. How can we make a number bigger? Let's say we don't want it to just be super, super tiny. Yeah, I'm going to stick with multiply first. So I could do times 10, right? I could do times 10, it's bigger. I could do times 20, it's bigger. But then your boss comes up and your boss, oh man, so mean, so rude. And she's like, we want this graphic to be really thin. And then you change this to be like ×2. Then your boss comes back and is like, no, we want the graphic to be really wide. And you're like, okay, great, ×30. And you keep having to change it and it's awful. And you never know how long anything is going to be. So what do? You use a scale. So I say color scale, scale linear, D3, domain. Our smallest possible city is how big in terms of population? Smallest possible city, not smallest city that we have. So yeah, so the smallest a city could be is 0. The biggest, let's just say 15 to give it a little extra space. Our output is going to be between, let's say, 0 and 400. And then I will say, now that I have this scale, take the population, of that city, feed it into our scale and get back a number. And then bam, it magically automatically works. Fun, right? So one more thing before we're done. One thing I hate is watching things change as I open up. Why is it called color scale? Because I decided it should be called color scale. So I'm going to double click HTML and I'm going to change all of these widths to 0 because I really don't like how it like flashes width for a while and then changes. And now I'm going to show you the secret. Are y'all ready for the secret? I don't know if you are. Okay. Dot transition with empty parentheses. Maybe dot transition, dot duration, 1500. And now magically it will grow from whatever the width and the fill is before your transition to be whatever the width and fill is after the transition. So anytime you look at someone's interactive D3 viz and things are like moving around and like shrinking and growing, just be like, I can do that. That's fine. I can do that. And so if you want to see what this looks like in real life, there is one more chart here that is actually, it's a completed chart. And it has tooltips on it using another library called D3Tip. And you can just look at the code and kind of understand what's going on here to a degree. So you can see that here I'm changing the width of something. Here I made some sort of scale that's colors. I made a scale that takes in 0 to 80,000 and gives me back something between 0 and the width of the entire graphic. This one is a scale between 0 and 90, which is the life expectancy, somewhere between the height of the graphic and 0. I read in some data. I set the CX, I set the CY, I set the fill using the scales. So it's the same sort of stuff that we did. It's just made much more complicated. But I think that you can probably give this a read through successfully without a crazy amount of work and kind of understand how things work. So that's the nuts and bolts of D3. This is how D3 works. It's the idea that you have scales that kind of relate your data to a visual representation of your data. So we'll probably end up with every row of your data as a rectangle, as a circle, as some sort of shape. Maybe if you're getting fancy, you're going to group together different, like group things by continent and make every continent a shape or something like that. Then your columns become something visual. For example, on this one, the columns of continent is the color. The column of GDP per capita becomes the X position. The column of life expectancy becomes CX or CY rather. So that's all D3 is. That's all D3 is. Like the programming part is awful. You become best friends with a lot of different punctuation marks, but the general idea is there. And it's not the worst thing in the world if you try to tackle it, I don't think. Any questions about D3? Was that a reasonable explanation? You kind of got the idea? You're welcome. You're welcome. Okay, so as opposed to Python and or R being the dominant languages for data, the dominant tool for web visualization is not a library, or not a language, but a library from a language. So it's more complicated these days. I will say that for interactive visualization, many newsrooms and people all over the place use D3 because you can get down to the very nuts and bolts of saying, I want to put a circle here, I want to put a rectangle here, I want to connect my scale, my data to my visual in a very specific way. But there are a lot of other tools that people use in order to do visualization, both libraries and other stuff. But I think D3, because it is so low level, and you can do so much with it, it takes a long time to do stuff in it. It's not something where you like whip up a project in 30 minutes. I mean, you could in theory, but it's probably better for you to use something like, let's say, Data Wrapper, which is a very simple way to make all kinds of charts and graphs without having to kind of get into the nuts and bolts of not just learning JavaScript, but learning the intricacies of D3. And so I would say that in D3, or no, in Python and R, there are actually libraries where you, like if you're working with data analysis in Python, you're usually using a library called pandas. If you are doing data analysis in R, you're probably using like tidy data or something like that. So there are libraries in every single language, and it's just strengths and weaknesses. So a lot of people just know about D3 already, so they build all of their stuff in D3. But it's not always, I would say, the best use of your time, but it is what people use for completely custom stuff. Does D3 afford any kind of interactivity? Yes, D3 can do anything and everything. If you look at this part 4 one here, you can see, if you look at the code, there's like a little add-in that lets you do this hover. You can listen for events. So you listen for people to click, for people to put their mouse over things, stuff like that. So yes, D3 is all about interactivity. Do you always have to use the letter D for function D? So no, but the #1 thing that I try to cram into people's heads when I teach is you want to program in the most boring, predictable way possible. So if 90% of the people on the internet, every time they do ATTR, if they use function D, you also want to use function D. Because when you have a problem, 2 things can happen. 1, you're going to paste your code on the internet for other people to read and to debug for you. If you're using standard ways of programming, standard ways of naming things, they're going to have a much easier time helping you out. #2, if you're stealing code from the internet, if I called this E every single time, because I'm like, it's an element, or if I called it city, or if I called it country or something like that, if I went back into my code and I cut and pasted this right here, because I'm like, oh yeah, it's that color scale thing that does the population, this code wouldn't work because I call it D right here. So it's just good to always call it D, because every single time you see code about D3, it's going to call it D. So you just want to fit in. Just want to fit in and be like everybody else. How many D3 sublibraries exist? 1 million of them. So the fun thing about programming is anyone can do it. And JavaScript is very, let's say it's very open. And there's just, let's see. Spelled library is wrong, but that's fine. So if you go to this list here, this list is a whole bunch of different plugins for D3. So things where you can do like bee swarms, box plots, all kinds of different stuff. So once you know the basics of D3, you don't have to reinvent the wheel. You can just find a library that uses D3 to make, let's say, a funnel chart. Why do none of these have pictures? Anyway, I assume that it works. I assume it makes some sort of funnel chart. So yes, there are a million and more people make more things all the time. You mentioned D3 has gotten more complicated. Yeah, so mostly this has to do with scales. Now, in the olden days, when you made a scale in D3, you would do d3.scale.linear or d3.scale.radius or something like that. And then you change it to now it's d3.scale.linear, scale radius. And I just feel like that made things unnecessarily complicated. That's probably 85% of what I mean by it got more complicated. Also, some things got taken out, put in. D3.q, there's something about now it's promises, but it's mostly just that scale thing. The anonymous function D is the part of the magic of D3 and the link to the data. So yes and no. So the way that it works is if I do .attr, that is a D3 thing. That is a D3 thing. And it says, you can give me two things. You can give me the attribute that you want to change and how you want to change it. Here's the attribute I want to change, and here's the thing I want to change it. I could call this function anything. I could write a function up here and then put it like this. So it's not necessarily there's only one way to do it. It's not necessarily this is just a D3 thing, but let's just say yes, it is a magic part of D3 that does that linking there. The fact that D is always going to be our data point, that is a part of D3. If I do DI, I is going to be 0, 1, 2, depending upon which element I'm on. This is all specific to D3. Yeah.